Hey everyone, good morning, good evening, based on the time zone you're listening to this video. This is my video recording for stretch assignment 5, Docker, Rancher, and Jenkins, right? And let's look at Docker first. So what Docker is all about. Okay, so the Docker is that Docker, okay, let's say for instance, we have a software that need to be deployed on multi-platform scenario, and it is like needed to make sure that the source code runs seamlessly no matter whatever the platform that we deploy the software to, right? So in this case, our traditional monolith deployment or even a service fabric deployment for this instance could work. But what is the host and kernel OS, and what is something the Docker, what is something the software package that we are shipping on top of the host operating system, right? And that is an installable. What we specify is an installable. But what if there are any external resources the software will have to access? And here is exactly where a containerization comes in, scores it in. Forget Docker for that matter. Let's think only about containerization, right? So it's a mere English word, container. It is to make sure that the source code, along with required resources, along with all the materials that is needed for the software to run, hosted in a relative path manner, not an absolute, but the relative path manner, it is bundled under one package, and that is shipped across operating system. And remember, when I say it is the resources that is needed to run a software that includes an operating system as well. That's the reason why the container, it is not just Docker. When you specify a container, that itself is heavy, because you are actually shipping the OS that is needed to run the software, a miniature version of OS that is needed to run the software along with. So it doesn't really care what platform that you are using to run the Docker container on, because it has everything. All it needs is there inside it. We don't even need anything additional. So wherever you ship, you're guaranteed that it is going to work the same way it is everywhere. So that is exactly where the containerization comes into picture. One popular container tool that we have here is Docker. So Docker is lightweight, portable, and flexible, and it is used to ship the softwares across environment, right? And the Docker containers are almost the modern day incarnation of any idea that has been in unique operating systems such as BSD and Solaris for decades, right? The idea that a given process can be run without a degree of isolation is from the idea that given process can be run with some degree of isolation from the rest of the operating system environment. Virtual machines provide isolation by devoting an entire operating system instance to each application that needs compartmentalizing, right? And this approach provides almost total isolation, but at a cost of significant overhead. Each guest operating instance sets up memory and processing power that could be better devoted to apps themselves. Containers take a different approach. Each application and its dependencies use a partitioned segment of the operating system's resources. The container runtime, here it is Docker most often, sets up tiers down the container by drawing on the low-level container services provided by the host operating system. To understand Linux containers, for example, we have to start with C groups and namespaces, right? The Linux kernel features that create the walls between containers and processes running the host. Okay, and the Linux namespaces, originally developed by IBM, wrap a set of system resources and prevent them to a process to make it look like they're dedicated to that process. Linux C group, originally developed by Google, governed this isolation and the usage of system resources such as CPU and memory for a group of processors. For example, if we have an application that takes a lot of CPU cycle and memory, such as scientific computing applications, you can put an application in a C group to limit its CPU and memory usage, right? Namespaces deal with the resource isolation for a single process, while C groups manage resources for a group of processors. Together, C groups and namespaces were used to create container technology called, appropriately enough, Linux containers or LXC, right? And how Docker changed containers. So in a way, Docker is a bit like virtual machines, right? So as we already discussed, and Docker allows applications to use the same Linux kernel, right, as the system that they are running on, and only requires application shipped with things that are not already running on a host computer. The original Linux container technology, LXC, is a Linux operating system level virtualization, for running multiple isolated Linux systems on a single host. Namespaces and C groups makes LXC quite possible. Docker introduced several significant changes to LXC that make containers more portable and flexible to use. Using Docker containers, you can deploy, replicate, move, and back up a workload even more quickly and easily than you do so using your virtual machines, right? Docker brings cloud-like flexibility to any infrastructure capable of running containers. Docker also makes it easier to coordinate between containers and thus build the application stack by hitching containers together, right? So more advanced version of those behaviors called container orchestration are offered by third-party product like Kubernetes. And here is exactly where we are jumping on to Rancher. So I will probably come to the management of container orchestration and Rancher a little bit later, right? Okay, what are the advantages of Docker? So we already did a lot about Docker, but what are actually the advantages of Docker? Docker container enables isolation and throttling. Docker containers keeps app isolated not only from each other, but from the underlying subsystem. This not only makes a cleaner software stack, but it makes it easier to dictate how a given containerized application uses the system resources such as GPU, CPU, memory, I/O, networking, and so on. It also makes it easier to ensure that the data and code are kept separate. Second advantage is Docker container enable portability. This is exactly what I had said in the very beginning. Docker containers runs on any machine that supports the containerized runtime environment. Application don't have to be tied to the local operating system. So both the application environment and the underlying operating system environment can be clean and minimal. For instance, a MySQL for Linux container will run on most any Linux system that support container. All of the dependencies for the app that are typically delivered in the same container. And the third advantage is Docker containers enable composability. Most business applications consist of several separate components organized into a stack. A web server, a database, an in-memory cache, and all that. Containers make it possible to compose these pieces into a functional unit that are easily interchangeable. Each piece is provided by a different container and can be maintained, updated, swapped out, and modified independently of each other. And they are essentially the microservices-based model of application design by dividing application functionality into separate self-dedicated services. And the fourth advantage is Docker containers ease orchestration and scaling. We will immediately jump to Kubernetes and Rancher and all that, but let me just give you a gist here. Containers are lightweight and impose a very little overhead. So it is possible to launch many more of them in a given system, right? And it's not just only the advantage. Docker also provides some caveats. Containers solve a great many problems, but they are not cure, right? After all, some of their shortcomings are by design. Some of them are by product of their nature, right? Docker containers are not virtual machines. Most common misconception is that Dockers are all virtual machines, but no. However, because of containers and virtual machines use different isolation mechanisms, they are distinctly different advantages and disadvantages to each other. Docker containers don't provide bare metal speed, meaning containers don't have nearly the overhead of virtual machines, but their performance impact is still measurable. If you have a workload that requires a bare metal speed, a container might be able to get you close enough, much closer than a VM, but you are still going to see some overhead. Docker containers are stateless and immutable, right? So Docker containers boot and run from an image that describes their content. That image is immutable by default. Once created, it cannot change. Docker containers are not microservices, As I mentioned earlier, Docker containers, lend themselves to creating microservice application, but they don't mean that taking a given application and sticking it into a container will automatically create a microservice. No, the developers will have to take care of all necessary steps, and it can just host a microservice, and it's not microservice by itself. It cannot do any heavy lifting for you when it comes to microservices architecture. Okay, that is about Docker. I think I gave a whole lot of information about it. Let me quickly jump on to Jenkins. What is that? And then see how does it work. When we talk about Jenkins, we have to really talk about continuous integration, right? Okay, what is Jenkins? It's an open source automation tool written in Java, used for continuous integration and continuous deployment purposes. In short, we call it as CI/CD. So Jenkins, as a continuous integration, is a development practice that requires developers to integrate code onto a shared repository several times a day. It's a process of running our test on a non-developer, say tester's machine, automatically when a push to a new code into the source repository. So let's look at an image quickly here. What does Jenkins is used for? Okay. So there's a huge advantage of knowing whether all the jobs work properly or not, right? Also, we can get fast feedback. The fast feedback is very important so that you will always know right after you broke the build. So in the console, you will get the detailed log of messages. From this, you will get to know what is the reason for the failure, and you can also get to know, how you can revert it back. Using an artifact repository, or in short, Artifactory, in a CI server will successfully deploy the build snapshot and release, which is available to other developers, right? As we know, it is for non-developers, like say, for example, the QA people, the testing people, to make sure that they get the latest code upon any successful push that happens to any Git repository or Bitbucket or any source control system that we use. Jenkins is easily pluggable to many of those source control systems that can quickly trigger the build and deploy upon any successful push. However, every single one of them is configurable by nature. You can have multi-branch deployment and multi-branch build and all that, so that everybody would push their code into an integration branch, and you can kick a build on an integration branch. Only upon successful, you can build that code to a development branch that can be opened up for many different developers. It can seamlessly integrate with Git, Bitbucket, or any source control repository, and it can easily deploy based on the script that we write. It can be a PowerShell script, it can be a custom script, it can be an Ant script, it can be any type of script that we write. It can also call a REST-based or SOAP-based API to pass the data that we wish to pass. For example, upon this successful build, call this REST API and pass this data to it. Sure, Jenkins can as well take care and then do it. And there are some of the advantages of Jenkins here, right? So Jenkins is an open source tool, which has much support from its community. The installation is easier, and it has over 1,000 plugins to make our life a lot easier. And it is very easy to create a new Jenkins plugin if one is not available. It's a tool which is written in Java, hence it can be portable to almost all major platforms. And that is exactly what Jenkins is all about. It's a continuous integration and continuous deployment tool, that can seamlessly take care of our the build and deploy processes. Let me quickly jump on to Rancher. And I will have to tie this up to very first Docker discussion, the Kubernetes, what we talked about. So Docker is nothing but a container, that can have a miniature of the operating system, the software, and the resources. And Docker can be, easily deployed onto, operating systems, and it can be scaled. But when it comes to orchestration, like for example, scaling up or scaling down, and automatically managing the containers of Docker and all that, you will probably need an orchestration tool that is available. So imagine a music orchestra. There is a music orchestrator who is there to instruct the group of what to do, what not to do, when to pass, when to raise, when to increase the tempo, when to reduce it, basically. So this is exactly the orchestration that is required for a container also. And one such orchestration tool is what is called Rancher. Rancher is an open source software platform that enables organizations to run and manage Docker and Kubernetes in production. So it is nothing but a container orchestration tool. Okay. Simply put, Rancher is a set of tool or a software platform that enables to easily deploy containerized environment. But they would make a Rancher just another orchestration solution. That is why Rancher operates on a higher level, leveraging other orchestration solutions to provide a unified control plane. In short, it's called UCP. Rancher can be easily installed on any machine capable of running Docker. Once installed, all subsequent nodes can be easily provisioned from the web UI, and with a few clicks, complex features such as load balancing that are available out of the box. The software, however, provides many more features such as infrastructure management, container scheduling, multiple environment, and monitoring health checks and logging. And when it comes to role-based access control, in short, what we call as RBAC, it can allow fine-tune permission and integrations with existing systems such as Active Directory and LDAP. And it runs anywhere where the Docker runs. And Rancher also has its own Rancher Compose format, and it also supports Docker Compose format. These two tightly resemble one another, which later being the more widely used, and it is not platform dependent. So, and it has a lot of application catalog, right? Rancher has an application catalog that enable one-click deployment of many popular software. In short, Rancher is a container orchestration tool. It can manage and run Docker containers, and it has like whole a lot of other advantages like monitoring health checks, and it can seamlessly back up and restore Rancher container to one other environment, as needed. When one container goes down, it can quickly scale up and then puts it onto other environment to make it run successfully, so that the users are not facing any downtime, and it efficiently manages the infrastructure as well. Okay, I hope I provided those three in a bit, and due to time constraints, and I'm actually stopping my explanation to only these three for now. This stretch assignment 5. Thank you, everyone. Thanks for watching.